Alright, this was a quiz about graphing rational functions. In this video, we're going to focus on analyzing a rational function that has already been graphed, and we will talk about the asymptotes, domain, range, increasing and decreasing intervals, as well as end behavior. Alright, clearly we have two vertical asymptotes here. We have one at -5, but we won't just put -5. We will put x equals -5 because that's a vertical line. All equations of vertical lines have equations x equals something. Horizontal lines are y equals something. So we have another one at +5. So we say x equals +5. And we have a horizontal asymptote at 1. So we put y equals 1. Now the domain. The domain is the x values of a graph. So we look left to right. The domain for this graph includes all real numbers except for these vertical asymptotes. Alright, every x value is represented except -5 and +5. So we can do that by doing it in 3 pieces. So this part of the domain comes in from -infinity to -5. So we will say -infinity to -5. We'll leave it round because you can't include the asymptote. And then union, and we'll pick up from here and do -5 to +5. Okay, that captures this middle part. And then to capture the x values of this last part, we'll pick up from +5 and say union +5 to infinity. So there's your domain. Now for the range, we're switching views and we're looking from bottom to top. Now we have to skip more than just the horizontal asymptote because this bottom portion of the graph doesn't go all the way up to the asymptote. It doesn't approach the asymptote. It stops right here at 0. So this bottom portion, it goes from -infinity down here, this is -infinity, to 0. So we'll say -infinity to 0. Also, this is not an asymptote. Alright, this graph touches 0, it hits 0. So I will use a square bracket to show that 0 is included. And then union. Now these top branches, alright, together, these y values start after +1, not including 1, so round parenthesis, 1 to infinity. So there's your range. Okay, now let's talk about intervals of increasing and decreasing. Maybe I'll just stick with this. This portion of the graph, okay, on the left, and you always read increasing and decreasing intervals from left to right. Okay, so from left to right, this portion of the graph is increasing because you can see how it's going uphill. Alright, so that's an increasing interval from -infinity to -5. Okay, -infinity to -5. Okay, that's increasing. We're just doing x values, so that's why we said -infinity to -5 because we're talking about x values, not y values. So it's not -infinity to +infinity or even 1 to infinity. All right, those are y values. So look at the x-axis when you're doing this. Okay, all right. Now we have another increasing part of the graph. All right, from left to right, increasing right here, but it's only increasing for this part of the graph. From here to here, that's increasing. After that, it starts going downhill. So another increasing part, so let's throw a union on that. Alright, so it's increasing, and again, x values, it goes from here to here, but those x values are from -5 to 0. Okay, so -5 to 0. Alright, these increasing and decreasing intervals are always round parentheses because right here at 0, for example, it's neither increasing nor decreasing. It's flat just for that instant. Okay, now, after that, it starts to become decreasing. Okay, because it begins to go downhill, downhill, downhill for this part of the graph. So this is decreasing from 0 to 5. So 0 to 5 is a decreasing interval. And again, we're just looking at the x values. That's why we're saying 0 to 5. Look at the x-axis. Okay, and then finally, when you look at this last branch, from left to right, this is also decreasing because of the way it goes downhill from left to right. So we'll stick a union, and then that's from 5 to infinity. So positive 5 to infinity, because we are once again looking at the x values. Okay? So that's your increasing, decreasing. Now, end behavior. As x approaches negative infinity, that means as we go to the left, what happens?
Bird.
End behavior. So going to the left, this graph is approaching the asymptote. Okay, it is approaching 1, because that's where the asymptote is. So f of x approaches 1. Going to the right, it's the same thing. As we head towards positive infinity, that's going to the right. On the end, the graph is again approaching the asymptote, which is at 1. Okay. All right, let's go ahead and dive into number 2. For the function below, graph the parent function, then translate. All right, we're just going to graph it. I'm not going to do all this parent function stuff, except for describing it. The parent function would be like this. F of x equals 1 over x, all right? That's the original parent function. Now, compared to that, we have three transformations. The plus 3 on the end here, that's a shift up 3. Okay, so up 3, all right? It's a vertical translation. Then there's this 3 right here, all right? That puts us inside the function, and that's going to be either a left or right motion, and it's the opposite of what you might think. So plus 3 will actually send us to the left 3. All right, and finally, we've got that 4 up there. Okay, well that 4 used to be a 1, so really it's like we're multiplying by 4. So that is called a vertical stretch. We call it a vertical stretch by a factor of 4. That's how you word that. So that's what we mean by transformations. Now, let's go ahead and talk about the asymptotes of this graph, because we'll need that to do the rest of the graph. So the asymptotes, first of all, the vertical asymptote. We get the vertical asymptote by setting this denominator equal to 0. So if we have x plus 3 equals 0, subtracting 3 from both sides, it gives us x equals negative 3. So that will be our vertical asymptote. Okay, so x equals negative 3. Okay, obviously that is a vertical asymptote. So let's go ahead and graph that. All right, great. So there's our vertical asymptote. Now let's talk about horizontal asymptotes. Well, the thing is, if it weren't for this plus 3 on the end, all right, let's pretend that wasn't there. Horizontal asymptotes, these are the ones where we have to consider the degree. Is the numerator degree less than the denominator? Is the numerator degree equal to the denominator? Is the numerator degree greater than the denominator? If it's less, then y equals 0 is the horizontal asymptote. If they're equal, then we do a over c, where a and c are the leading coefficients. If the numerator degree is greater, then there is no horizontal asymptote, although very soon we're going to learn about slant asymptotes, but we'll talk about that later. Now, for this one, the degree of the numerator is 0, okay, because there are 0 x's up here. All right, or you could think of this as x to the 0 power. Now down here, this is like x to the 1 power. This is the degree of 1. There's 1x, whichever way you want to look at it. So the degree of the top is less than the denominator. Therefore, we're in the y equals 0 situation. So that's what it would be. Okay, y equals 0. In other words, we would, maybe I can just steal this. Hold on. All right, so we would have an asymptote at 0 if this were the function. But as we discussed a moment ago, sticking a +3 on the end of any function is going to cause a vertical shift up 3. Okay, so our function would have had a horizontal asymptote at 0, but a vertical shift will cause this thing to move up 3. Now, a vertical shift does not affect a vertical asymptote because it goes up and down forever as it is. So moving a vertical line up or down is meaningless. All right, but a horizontal asymptote, you can see it move when you move it up 3. Okay, so the horizontal asymptote is actually here at 3, not 0. So very important. So that's why we'll have our horizontal asymptote y equals 3. All right, I hope you didn't put 0. Hope you weren't thinking 0, because that would be wrong. Now we got the asymptotes. Once we got that, we can start talking about the x-intercept, y-intercept. Okay? Now in general, if you want to find the x-intercept, you know what you do? You let y equal 0. If you want the y-intercept, you know what you do? You let x equal 0. In other words, for the x-intercept, plug in 0 for y. For the y-intercept, plug in 0 for x. Okay, so that's what we're going to do. So for the x-intercept, let's plug in 0 for y and see what happens. This is y, by the way, in this context. So if I plug in 0 for y, okay, then this is what I'm going to have. I will have 0 equals 4 over x plus 3 plus 3. Okay, so I need to solve this for x. So, you know, subtract 3 on both sides. So what do I have now? I have negative 3 equals 4 over x plus 3. What will I do now, you say? Well, that's a good question, I say. So I say let's multiply both sides by x plus 3. Okay, let me do it like this. X plus 3. Okay, these are going to cancel out. Kabam! Okay, over in this area, I think we should do the distributive property. So I'm going to do that now. All right, if I do the distributive property, negative 3 times x, so I've got negative 3x. And negative 3 times positive 3 is negative 9. Okay, these cancel it out. So over here I just have 4. Now I'm trying to solve for x, so I just keep going. I add 9 to both sides. 9. Negative 3x equals 13. And next I'm going to divide by negative 3. Okay, last night was the season premiere of The Walking Dead, you guys. It was crazy. It was so crazy. I was so scared. So I'm gonna, here's my x. I've got negative 13 over 3. I mean, at one point it looked like this guy was gonna, you know, harm this baby. I was like, what? I mean, even by Walking Dead standards, that was crazy. But the baby was okay, so everybody can relax. The x-intercept, since this is the x value, since this is the x-intercept, I'm going to put this for my x value. Negative 13 over 3. The y value, of course, is 0. And I might as well graph this as well, but I need a decimal. So negative 13 over 3. Okay, I got to move this a bit. All right, so negative Ghost Rider negative 13 over 3. All right, it gives me the same thing. I toggle it, so that's negative 4.3. All right, just keep that in the back of your mind, that this is negative 4.3 approximately. But let's go ahead and graph it. So we have an x-intercept of negative 4.3. There's negative 3, negative 4, negative 4.3 would be like right here. Of course, it's on the x-axis. It's the x-intercept. Now let's find the y-intercept. So I'm going to let x equal 0. Okay, so I'm coming back. This time I'm plugging in 0 for x, and I'm going to see what happens. All right, if I plug 0 in for x, okay, then I'm going to have y equals 4. Now that's 0. I'm not even going to write that down. I'm just going to go straight to over 3 plus 3. All right, basically putting 0 in for here, it's like you can scribble it out. So that's it, you know. Let's just see what this is. 4 over 3 plus 3. I mean, I can do this by hand, but whatever. Okay, 4 over 3 plus 3. So, that's 13 over 3. Let me go ahead and write that down. So 13 over 3. That's the y-intercept. So since this is the y-intercept, I'm going to put this down as the y value, 13 over 3. So of course the x value is 0. Yeah. So we saw that negative 13 over 3 was negative 4.3. So guess what? Yeah, you guessed it. This is positive 4.3. So let's go ahead and graph that. Y-intercept. So there's 3, there's 4, here's 4.3. Okay, now, so we have a couple of points, but let's get some more points going. So to make our table of values the way we want to do, you really need to look at the vertical asymptotes. Well, in this case, vertical asymptote, singular. Wait, let me make sure that there's not a table of values waiting for me already. Nope, I'll make my own then. So here I go. I need a couple of values on the left and the right of this vertical asymptote. So for example, I will choose my first two integers to the left are negative, okay. This is 0, so this is negative 3, negative 4, negative 5. So I'm going to use negative 5 and negative 4. Okay, those are my first two integers. But I will also do the decimal here, okay? Negative 3.5. Okay, always do the decimal to the left and right of the vertical asymptote. You want to know what's going on up close to the asymptote. Trust me, just trust me. All right, weird things happen up close sometimes. Similarly, as I jump to the right-hand side of this, that would be negative 2.5. Let's definitely include that. Maybe I'll put a line here to show that this is where the asymptote was. So negative 2.5. And then I'll go ahead and do some integers here. So that would be negative 2 and negative 1. Okay, so this would be a good representation. All right, because plus we have the x-intercept and the y-intercept. So we find these 6 values, we're doing pretty well. How will we find these values, you ask? Well, I'm glad you said that, because it gives me a chance to say TI-30 XS multi-view. All right, so you hit your table button, and so we have 4 over x plus 3 plus 3. Let's take a look at what we got. Now, I want to start off at negative 5, so I'm just going to tell it negative 5, please. All right, so at negative 5, we've got 1. So let's see, at negative 5, it's 1. At negative 4, we have negative 1. All right, let me skip these decimals for a minute. I'll come back to them. How about negative 2 and negative 1? So I'm going to scroll down. Okay, at negative 2 is 7, negative 1 is 5. So 7 and 5. Now how about those decimals? Well, here's a nice way to get the decimals. Hit your table button again, hit enter again. But this time, instead of doing auto like normal, try ask. Why don't you try asking for a change? Use your manners. Okay, ask is saying, what would you like, sir? How can I help you? Well, I'd like to see negative 3.5, please. So you just type that in, negative 3.5. I missed a decimal. And it just tells you that particular value. So that's negative 5. All right, would you like to see negative 2.5, sir? Yes, I would like that very much. Or ma'am, if you're a girl, woman, you know, girl, woman, young lady. I don't know who you are. Don't yell at me. Negative 2.5. But I'm supposed to see through the computer and know what's going on over there? Yeah. You expect too much from the internet. So we have these values. Now let's go ahead and graph these and see what we have. So negative 5, comma 1. So this is negative 3, negative 4, negative 5 is at 1. Negative 4 is at negative 1. Okay, and then we have negative 3.5, okay, which is right here, is at negative 5. So I might gotta scroll down. So 1, 2, 3, 4, 5. Okay, and let's continue. Negative 2.5 is at 11. So right here, I'm all the way up like here at 11. And then at negative 2, I'm at 7. Okay, 3. All right, and at negative 1, I'm at 5. All right, so this is enough information for us to draw the curve. So over here, all right, it must be doing this type of thing. Okay, got a little, all right, crooked in there, but you know, good enough. And over here, it must be doing this type of thing. Oh, I skipped a little. That's gonna bug me. Let me try that again. Okay, I'm sliding, slide. Why is it so jerky? All right, you know, I'm gonna do this off camera. Okay, that's not too bad. All right, so let's finish up this problem. The domain and range. Well, the domain is how far the graph goes from left to right, the x values. So the domain is everything except for, it's all x values except for this vertical asymptote. Got to skip over that. So negative infinity to negative 3, and then negative 3 to infinity. Okay, so negative infinity to negative 3, union negative 3 to infinity. And remember, the domain is strictly x values, so that's why we're saying negative infinity to negative 3, and then negative 3 to infinity, because we're just looking at the x-axis when we say that. Okay, round parentheses, because you can't equal negative 3. Now for the range, same type of thing, but now we're looking at the y values. And this time it's the horizontal asymptote that has to be skipped. You know, even though it looks like it touches, it really doesn't touch. Never, it approaches the y, the horizontal asymptote never touches it. Okay, so the range will be from negative infinity to positive 3, and then positive 3 to infinity. Okay, so negative infinity to positive 3, union positive 3 to infinity. So there's the range. Okay, I think that's it for this problem, and that's all for this page. Okay, so I'm going to go ahead and stop this video here because it's plenty long enough. Okay, and we will pick up the next video will involve another graph from scratch, but it's a little bit different, so stay tuned. I'll give you a hint. There's more than one vertical asymptote. Weirdness. All right, I'll see you guys on the next video.